Okay, video's rolling.
Yeah, yeah.
So, do we continue? Now, for people listening at home, that means half the class. Hi, John, Jack, Noah, Pete, Julia. We miss you. But we're just talking about domain. Refresher course. There are three, this is going to take like a minute. There are three illegal things you can do now. Divide by zero, square root a negative, and take 0 to the 0 power. Just ignore this thing, this was just kind of a side tangent. So what we're trying, we're looking to see, what is the domain of this? Let's just say I'll call this like h of x. So what x's would be legal to plug into this thing? What we know is that the inside cannot be negative. Cannot be negative is another way of saying has to be greater than or equal to 0. Think that makes sense? Because 0 and up are not negative, those are safe. Anything below 0 is not safe, that's negative. So, I know that x squared minus 6x minus 7 cannot be less than 0. So it's got to be greater than or equal to 0. How do we solve this? We did that last chapter. Factor it, and then I'm going to use plus minus notation. If we're used to doing this with a fraction, with a whole bunch of roots and a whole bunch of vertical asymptotes, there aren't any vertical asymptotes here. There's just two roots, 7 and negative 1. Solid dot, solid dot. Can somebody talk me through this? What number would you test? What would be nice and easy? Go for it. 0. So that'd be the middle region, try x equals 0. And plug it in here. So what is this? So h of x is equal to what? Something times something. And I want to know if the answer is positive or negative. Plug in a 0 here. What would that be?
That's going to be negative.
Negative?
And then positive.
Correct. So negative times positive is
Negative.
negative. This region is negative. What about this region?
Positive.
Positive. It's a single root, so it'll switch. How about here?
And then positive.
Another positive, because it's a single root, it'll switch. Which regions are we interested in? The positives or the negatives?
The negative. Wait. Oh, sorry. Greater than 0.
Right. We're looking at the positive regions. So name them. Give me my final solution. X belongs to
Down bracket, negative infinity.
comma
Negative 1.
good. Do you want to include negative 1?
Yes.
Yes, because it's safe and they want it. Okay? And then union.
And then you have 7
Uh,
round bracket, or
square
square bracket.
bracket. It's safe and they want it. Comma.
Comma infinity.
Infinity.
And then round.
And that is your domain. In other words, when you're using this and graphing this, you can use any numbers except the numbers between negative 1 and 7. When you're doing a table, don't waste your time plugging these in, because the graph ceases to exist in between them. Does that make sense? If you actually graph this thing, it looks kind of funky. If you have, here's negative 1 and here's 7. It looks kind of sort of like this. It's kind of,
Oh, I'm muting. I'm sorry. I didn't know.
we're videotaping it for you.
Oh, okay.
We actually said hello to you on there, so. You'll, I'm sorry. But yeah. It's going to be a homework assignment, but I'll email it to you.
Okay, thank you.
It's relatively brief. I'm actually working on typing up homework guide sheet as we speak. So, yeah.
So, I need my book.
Yes, that would be a good idea. Good catch. Okay. Yeah. The guy just showing up. Hey, different fingers too. That one happened. See, like that?
I like how you walked like directly in front of the camera just
So,
to do that.
yeah, I'm not going to trust my wife. Moving on. I'm going to give you a graph, and you give me the domain. Let me scooch this stuff out of the way.
I can do this.
So instead of a formula, I'm going to give you a graph. I'm going to give you this as blob. Can somebody give me the domain of this thingy? I'm gonna call it f of x. By the way, it's not a function. It fails the vertical line test. It's just a plain old relation. But I want to use the domain anyway. Good practice. What x's are legal? How do you know which x's are legal in a graph? It's the x's that they actually use. Can somebody name them? What x's are being used? Michael, take over. For example, did this graph ever use x equals 0? The graph is this blob, this sort of racetrack thingy.
I don't think so.
So pretend they take, like, here's a paintbrush dipped in paint, then they went smear, 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 smear. Did they cover anywhere where x is equal to 0?
Where x is equal to
X is equal to 0.
Yes.
Yes. As a matter of fact, how many times?
Twice.
Here's one, and here's the other. Yes. So did they use x equals 0 ever?
Yes.
Yes. Did they use x equals 1? Julie, you should. Yes. That's right. Remember, this is 8. This is 8 spaces over. So it's right around here. They hit it twice. So x equals 1 is one of the ones they used. How about x equals 1/2? Sophie. Did they use x equals 1/2 any time?
Yeah.
Yeah. If they use x equals 1, then they definitely used x equals 1/2. Holly, did they use x equals 7?
Yeah.
Yes, because it's still to the left, like right here. They used it twice. Michael, did they use x equals 8?
Yeah.
How many times?
Once.
Once. Julie Sushon, did they use x equals 9? No, that's too far out. Did they, did they use x equals -7? How about -6? Yes. How about -5? Yes. What x's did they use? Total. What interval?
Square bracket -6 to square bracket 8.
Got it. -6, comma 8 square bracket, and what do you put in front?
X belongs to.
X belongs to. Exactly. That's how you do it. Make sense? So visually, you kind of have to do it by hand.
Yeah.
You say, but it goes all the way to -6 to the left, and all the way to 8 to the right, and all the numbers in between are covered somewhere, usually twice. Boom. That's it. I'm going to give you one a little more tricky. I'm just going to do dashes here. This is like, I'm counting by ones. I need to submit myself to psychological examination as to why I keep doing alouette or jote alouette whenever I do a math problem. There's got to be some explanation. Does that ever teach psychology? Mr. Ayers or something? That'd actually be kind of fun, sitting on his couch and, Mr. Ayers, I have issues. He said, tell me about them.
Jeepers and flip out.
I don't know. No, that was a different one. So there, that is the entire graph. This is g of x. So can somebody give me the domain? Quick question. Did they ever use x equals 0? So in this graph down here. Yes, they did. How many times? Once, right here. Did they use x equals 2, Julia Sushon? Yes, they did. How many times? Get the next question as well. Did they use x equals 1/2? No, there's a gap there. They'd use nothing in between 0 and 1, or between 1 and 2. How many numbers did they, first of all, how many numbers did they use up here? Trick question. Anybody? Infinitely many. There's bucket loads of numbers in between. Holly, how many numbers did they use down here? How many x's did they use?
Is it 5?
5, and none other than that. How do you list 5 individual numbers?
Do you just give the points?
Yeah, well, actually, I just need the x's for domain. Think back to the beginning of the hour. How do you do individual, what we call discrete numbers? We filmed the stuff that you missed. Watch YouTube when you get here.
We got attention.
Learning stuff for fourth graders.
Oh.
Michael explained this whole story, like, that Rebecca thought.
Yeah, wait.
Oh my gosh.
You.
I thought that's why you guys all, why didn't I get to go? Let's go.
Because we're not understanding.
Yeah, the first video.
Oh. That's the.
Seriously? Alright.
It's just all the fourth grade.
I had actually heard about this, then I thought this new story superseded that old story.
Yeah. It's the city of London.
Well, what, doesn't it
And
say,
like the
Alright.
paper, like call it like the London city, and stapled all together in a ring.
And you burn it.
And
Okay, we're filming, y'all. Later. Okay, catch you up on what we just did. When y'all left, we were doing plus minus notation on this. We ran it. There are only two roots, so you just boom boom. I tested 0, they came up negative. So this is positive, this is positive. And since it's greater than or equal to 0, we wanted the positive regions, so I grabbed this and this interval. Make sense?
Yep.
Now, what if I just give you a graph and I say find the domain? Remember, the domain is just interested in the x's. What x's did they use in this? This is like a sort of a twisted racetrack. Let's say it's like a dirt bike racetrack or something like that, where they want people to swerve and kill themselves. So, I'm sorry, comment. So, what x's are used here? Actually, people that just joined us. Jack, did they ever use x equals 0 in this graph at all?
No.
Like, in other words, pretend this is like with paint. Did we ever cover a point?
Yeah.
How many times?
Like,
How many times did they use x equals 0? Like, how many times did the paintbrush cross x
probably
equals 0?
multiple times. Like, could be infinite.
Actually, there's
Or
only
one.
2.
Oh.
Where are they?
Uh,
We don't know exactly the height, but
we're kind of to the very edge
Above?
of the, yeah. And
Below.
Oh.
in other words, dot here, dot here. Does that make sense?
No.
So in other words, if it crosses x equals 0, bam, that's the point I want. So,
Just
no.
x equals 0.
Did they cover x equals 1?
X equals 1.
Did the graph ever use x equals 1?
Doesn't really look like it.
Here's x equals 1.
Oh. Yeah.
Yes, how many times?
2.
The reason I knew it was that far, because this is 8 spaces over.
Okay.
Does that make sense?
Oh, yeah.
So did they use x equals 7?
Yeah.
Yeah. Pete, did they use x equals negative 2? Yeah. Did they use x equals negative 6? How many times? Only once. That was barely at the edge. Did they use x equals negative 7? Never. So the interval they used is from negative 6 to 8 included. Does that make sense? That's how you get a domain from a picture, from a graph. We are now doing this one, and we're just trying to figure out exactly what that is. Here, they use an infinite number of x's, but they're contained between negative 6 and 8. Square bracket, square bracket. This thing, there are 5 individual dots, and that's the entire graph. So quick question. Jack Cloud, did they use x equals 0 in this second graph down here?
Yeah.
Yes. How many times?
1.
Once, right here. Did they use x equals 1/2? Good. No. No. How do you know?
There's no 1/2 bar.
There's no dot anywhere on x equals 1/2. Exactly. They just skipped over it. As a matter of fact, they skipped over everything between 0 and 1. Did they use x equals 6? Julia Cichon? No, that's too far over. Did they use x equals negative 1? Yes. Negative 2? No, that would have been too far. So refresh my memory. How many x's did they use? 5. And only 5. We cannot use an interval because an interval will cover an infinite number of things in between. How do we list individual numbers? Anyway, go. Curly brackets. Curly brackets, and then list them in order, from smallest to biggest.
-1,
Huh?
0, 1, 2, 3.
Correct. Any questions? Now again, I don't care what the y's are. I want to know what the x's are. for range, we're gonna use the Y's. Is that gonna make sense? Alrighty. Tell you what, I'm going to give you a homework. I did not have a homework guide sheet for you yet, so you have to write this on the board. I'm gonna work on it over the weekend, right from my computer. This is gonna be homework number 4A, or is it 4 or 3A? No, that's 4A, yeah, because you already did chapter 3. So it's going to be pages 122 to 120. You.
My favorite one.
Yeah, ignore 124. 122 to 123. I'd like you to do numbers 1 through 6. And then 9A through 11A. And that's all I want you to do for now. 1 through 6, 9A, 10A, 11A. I should just list those separately. 9A discreetly, 10A, 11A. Okay? You're welcome to start it on that. I will write it on the board. And I think that's all we need to videotape. So, Julia, we miss you. See you later. Get well soon. Or whatever is going on there. Return to us quickly. Talk to you later.